Hello everybody and welcome to another YouTube video. And in today's video we are going to be talking about the concept of the multinominal logistic regression. So I actually say this is a type of binary logistic regression that is on steroids, because your binary logistic regression is basically used to predict a dependent variable that is categorical in nature and also has just two levels or two outcome, and we have several independent variable. But your multinomial logistic regression has a dependent variable that is categorical but have multiple levels. It has multiple outcomes. So in summary, your binary logistic regression is about two outcomes, and the multinomial logistic regression is about more than two outcomes as the dependent categorical variable. You might want to check out the previous video where I actually talked about the concept of the binary logistic regression. So I'll be using this car data set right here to actually perform the multi-nominal logistic regression. Okay, I have a total of 27 variables right here, and a larger chunk of them are actually numerical in nature, and they are obviously on the interval scale. And I have a couple of string variables, I can say categorical variables right here, that do not really have numerical values. So we come to analyze, okay, then we'll come down to regression, and you can see the multi-nominal logistic regression. We click on that, and we are actually introduced to this dialog right here. It has a dependent, it has the factors, and it has the covariate. You will notice that this is quite different from the binary logistic regression output box, because for binary we don't have the factors, okay, so we only have the dependent and the covariates. But this time we actually have the dependent, the factors, and the covariate. So the dependent variable is the variable you're trying to predict, so it goes right in here. Now the factors are going to be consisting of the categorical variables that you are actually working with. Okay, so all your categorical variables that you want to work with goes inside here, and your numerical variables actually get inside here. Your covariates are also known as the independent variable. So we come right here. So I want my dependent variable to be the fuel type, okay, so either gas or diesel. So I drop that right in here, and it brings out this simple dialog right here, that is the reference category. Now if you notice, Spss chose last. It simply means that if it's going to calculate the odd ratio of this dependent variable, it will be doing it based on the last category, and we have two categories right here, that is gas and diesel. So diesel is the first and gas is the last. I think okay, gas is the last rather. Sorry, gas is the first and diesel is the last. So that means if it's going to be calculating the odd ratio, to be doing so based on the chance of the car being a diesel car and not a gas car. And if you want to change that, you can just click right here and change it to first. Okay, click on OK. So that simply means if you're going to calculate the odd ratio, it will be based on the first category, which in this case is actually gas, you know, because if you check this right away, I have gas and then I have diesel, so that is the reason why. So gas first, diesel last. So let's just go with first. So that means our odd ratio will be calculated based on gas. So our factors, so I'll be using just a couple of factors, not really so much to bombard our system, our model rather. So I'll be using the for system, okay, this, and then I'll also be using the aspiration. This is actually fine by me. All right, so for the covariate, I would like to introduce the price, and then I would also like to introduce the car height. Okay, now I have a total of 5 variables. In this case, we have just one dependent, we have 2 factors, and we have 2 independent variables. Now we can come to the model, and you will see this dialog right here. If you feel like there is actually an interaction between these 4 variables right here, I click on custom. If you feel like probably the price of a car is actually been interacting in real life with the car height, or the price is interacting with the aspiration, then you can make up for this interaction, this effect right here, because if you don't make up for them right here, it's going to have an effect on the model that you're trying to build. So if you feel like car price, car height, aspiration, force system are in one way or the other affecting each other. You have to make reference to that interaction, make reference to that effect right here, because it will definitely affect your output, your regression model. So for now, I won't make any interaction or make any effect because I'm assuming there is no interaction. Okay, so for the statistics, so you can actually click a lot of things. We have the case process summary by default being clicked. We have the pseudo R squared. What this simply means that, so a logistic regression is not fully numerical, so we don't have a full R squared. The R squared, by the way, is the coefficients of determination. It helps us to define the amount of variation in a dependent variable that can be explained by the independent variables. So since we don't have a full R squared in the binary or the multiple or the multinomial logistic regression, rather, we are going to be using the pseudo R squared. So the pseudo means false R squared, but it's not really like a total R squared. So I would like to have the information criteria, the cell probabilities, the classification table, the goodness of fit. I think I'm okay with that. Then for the parameters, I would like the estimate, I would like the likelihood ratio test. I would also like a 95% confidence interval for the exponential of the slope of the model, or the estimate rather, and that is also known as the odd ratio. So aside that, I think I'm good. I click on continue, and you don't need to touch anything right here. So we click on OK. It runs the code and it actually gives us all the things we need to know. So the first piece of information we are actually met with that is relevant is that the case processing summary. Now we have basically the categorical variables. So we have the fuel type, the fuel system, the aspiration. So the number of cars that are diesel, we have 20, and the marginal percentage that they constitute. We have for gas, we have for 1 BBL, we have for 2 BBL, that is for the fuel system, and we have for the aspiration, which is either STD or turbo. Okay, so it also gives us this number of valid and missing and nothing really spectacular. This is more or less like a summary of the variables that defines our data set. Now, when we come to the next dialog, we see what we call the model fitting, and this actually helps us to tell us how accurate our model is based on the parameters we actually throw into it. So we have two details, or we have two parameters that can help us define how fitted our model is based on the parameters or the variables that we inject into it. Now we have the AIC, which is called the archaic information criteria, and we have the BIC, which is the Bayesian information criteria. You can decide to use either of them. It's fine. It's not a big deal. So now, the lesser this number, I'll be using the AIC, by the way. So the lesser this number, the more accurate your model is, and the higher this number, the less accurate your model is. So this AIC is kind of restricted, or is kind of strict rather, on adding so many variables into your model. So you have to pay attention to that. And like I said earlier on, you can use between AIC or BIC. Then we have the goodness of fit. And for our goodness of fit is all about if the distribution that defines our data set as a whole can actually fit into that of a normally distributed data. That is, we are trying to compare the distribution that defines our data set and the one that defines a normal distribution. And based on the Pearson chi-square test statistics, our test statistics is actually 0. Our degree of freedom is 189, and our test rather, that is our goodness fit, is not significant, which simply means this data set of ours does not in any way fit into a normal distribution. All right, so we have a pseudo R squared right here. That's we have 3 values that can actually define the pseudo R squared. We have the Cox-Snell, we have the Nagelkerk, and we have the McFadden. Okay, and funny enough, we have a R squared that is actually 1.00. That means that there's a perfect fit in this model of ours based on the second pseudo R squared, and also a perfect fit based on the McFadden. Now these two values are actually too ideal, and it might come as a result of the fact that we introduced some variables that we are not supposed to introduce into the model. So you will notice that once I remove 1 or 2 variables or add some couple of variables, it's going to like change all of those values. So the likelihood ratio test, we can actually skip that. It's really not needed for now. And this is one of the most important parts, if not the most important part. So please don't forget that our fuel type is actually the dependent variable, and it has just two outcomes. We have the gas, and then we have the diesel. So we have B, which represents the slope. We have the standard error. We have the world, which is the test statistics. And for some weird reasons, we have 0, 0, 0, 0, 0 as our test statistics. That is actually weird, but it means some of the variables are not supposed to be where they are. Now we have the significance, and we have the exponential of B, which is actually the odd ratios. Okay, as you can see, we have 1.00, 1.00 all down here. That means none of the variables, that is the covariates and the factors, are actually in any way affecting the fuel type of a car, meaning the price does not affect the fuel type of a car. So meaning a gas car is not expensive compared to a diesel car. Also, the fuel system is also insignificant to this, and then the aspiration is also insignificant to this. Now, we can actually feel like this is wrong and then try to inject a better variable into our model. All we can do is to come to analyze, come to regression, multinominal logistic. So this time we can probably remove the car height, then try to like get in something like the stroke. Okay, then for the factors we can probably remove the fuel system, the aspiration, then we actually probably introduce the car body, and we can see that is okay. So let's just have like the car body, the price, and the stroke. So we are trying to predict the fuel type based on the car body, the price, and the stroke. So we click on OK, it runs the test, and we have this. Now, as you can see, it gives us the summary. We have the fuel type, we have the car body, and that is that about that. Now, the archaic information criterion has actually increased. So that means that the model has actually reduced when it comes to the accuracy. The accuracy of the model has actually reduced. When it comes to the goodness of fit, talking about the Pearson chi-square, it is actually not significant, even at a 5% level of significance, but the significance are actually reduced. We can see that our pseudo R squared actually kind of make more sense right now. So we have 0.277 for Nagel-Kirk, we have it's 0.219 for the McFadden, and we have a 0.131 for the Cox-Snell. Then we can come right here. Now, the slope, the standard error, the wild, the degree of freedom, the significance, and the odd ratio. We can see that the price is still not significant to the fuel type. So our model is telling us that because a car is gas or diesel does not mean the price of the car should actually be affected. So there's no relationship or no kind of significance between car price and the type of fuel type and the type of fuel rather that it uses. So the stroke obviously is significant, so which actually makes sense. The stroke of a diesel car is very significant and very different from the stroke of a gas car. The convertible, the car body, now the car body is in no way significant to the fuel type. So because a car is a sedan, a wagon, a hatchback, or a hardtop, does not have any effects rather on the type of fuel that the car is using, which actually makes sense. So this model of ours is actually a good one that we can actually work with, even though the model fitting information is kind of like a bit less accurate compared to the first one. So let's come to the classification table. As you can see, we have observed right here and we have the predicted right here. Now we have diesel, gas, we have diesel, we have diesel, we have gas, we have diesel, we have gas. Now this zero value simply means that we have an observed number of zero diesel car. Okay, and then our model was able to predict that we have zero diesel car. Now this 20 simply means that we have 20 number of diesel car, but our model was predicting 20 number of gas car. So that means our model was a bit wrong, right? It was wrongly predicting that we have 20 number of gas car, when in fact we actually have 20 number of diesel car. All right. This 3 right here says that we have 3 number of gas car as the observed, like the actual value, but our model mistakenly predicted them as 3 number of diesel car, and right here we have 182 number of gas cars, and our model also predicted them as 182 number of gas cars. So this is the percentage accuracy, if I can use the word. And so we have the observed and predicted frequencies. I think that's just all of that. And as you can see, so you can actually play around this model and try to like throw in 1 or 2 variables to see how you can increase how you can decrease this value rather, to make your model more fitting, and at the same time increase the value of the pseudo R squared. So that is the beauty of the multinomial logistic regression. If you learned something new from this video and you also kind of enjoyed this video, I would really appreciate if you can give this video a thumbs up and also subscribe to this YouTube channel. Do you think I missed something, or you have some questions for me? Please don't hesitate to go to the comment section and drop your question. I'll be willing and be also ready to attend to all of your questions. Thanks for making it to the end of this video, and we'll see you in the next one. Bye for now.